Hello. Wait, this is in my way. Don't judge how many tabs I have open. I am busy. Okay, this is lesson 5-1, Powers and Exponents. It's the first lesson in book 2, which is super exciting. And also, hey, I moved this out of the way. What is going on? Also, it is kind of cool and also very important because you're going to encounter these exponent thingies a lot. So here we go. Lesson goal. Students will write and evaluate superpowers. Just kidding. Sorry. It's not that exciting. Just powers. And you'll see what that means as we continue through the lesson. I don't know why there's an extra period right there. I guess for fun. All right. Products as powers. And in terms of products, what we mean here is not things you buy at the store. We are talking about products as in the solution to a multiplication problem. All right, so a product of like factors can be written in exponential form using an exponent and a base. That's fancy words. You especially need to know exponent and base. A number expressed using an exponent is called a power. The base is the number used as a factor, and the exponent tells how many times a base is used as a factor. Jumbly words, it'll make more sense as we go. So there's an animation that you don't really need to see. I'm just going to explain this here. So the factors that we're talking about here we're thinking just like numbers that we're multiplying together. And so in this situation here, we have 4 of them. We have a 3, another 3, another 3, and another 3. In total, that is 4 different 3s, and we're multiplying them all together. So these are the factors. There are 4 of them. And we can write this out as an exponent like this. 3, that's the factors that we're multiplying, to the 4th power is what that means. And so we have a 4 here because we're multiplying it 4 times. So use an exponent to express the number of times 3 is used as a factor. So 3 times 3 times 3 times 3 is the same as 3 to the 4th power here. Okay, and so that's the exponent, the 4. Here is a little diagram showing you what the numbers are. So the 3 in this situation, in this example, is the base, and the 4 is the exponent. The base is the common factor that is being multiplied. Notice it's a common factor. It has to be like the same number over and over again. And the exponent tells us how many times the base is used as a factor. So if there were 2 other 3's over here, then this would be a 6 instead of a 4. Okay, so we can label each part of the equation using the words below. Please fill this in if it's not already filled in your books. We've got factors. Those are these tens right here. We've got exponent. That's our little 2, which is because there are 2 factors. We've got power, which is the whole thing together. The 10, the base here with the exponent together is a power. And then the base is 10. And that comes from what the factor actually is. Okay, so you don't have to write this, but I just want to talk about this. Explain the difference between a base and an exponent. The difference is the base is the factor, it's the big number, and the exponent is the little number that is talking about how many times we are counting or multiplying the factors. Okay, so base, big number, that's how I remember it. B for base, B for big. Okay. You also can think of exponent for like extra. Some people do that. So here's example 1. Write products as powers. Write 7 times 7 times 7 times 7 times 7 using an exponent. Now, obviously, we could just solve that without an exponent, but it gets messy, especially as we start to have longer chains of these. So instead of writing it like that and doing all those 7s, what we can do is we identify that the base is 7, because that's the number that is repeated over and over again, and we can count them, and there are 5 of them. 1, 2, 3, 4, 5. So that means that we can write this like this, 7 to the 5th power. Okay, 7 factors, 5 times. Try it out yourself. We've got 8's here. Figure out how to write that using an exponent. All right, we can also do this with fractions or any rational numbers, honestly. So if we have 2/5 times 2/5 times 2/5, we could write that using an exponent as well. The base is 2/5 in this case, and there are three of them. So we would write this as 2/5 to the third power. Again, you don't need to write this, but why are the parentheses used in 2/5 to the third power? Well, it's simply just to make it obvious what's going on here. When you have a fraction, the numbers get smaller, and you don't want to get it confused with that exponent there and make it look like accidentally 23/5 or something like that. So it's simply for ease of reading. Try it out. Write 1.5 times a million times. Yeah, try this one out. Write it using an exponent, and don't forget those parentheses. All right, next section, powers as products. To write powers as products, this is basically going to go the other way around. To write powers as products, determine the base and the exponent. So the base of 3 to the second power is 3, big number, and the exponent is 2. To read powers, consider the exponent. The power 3, we can also say 3 squared here, 3 to the second power, is read as 3 to the second power or 3 squared. Wow, I said that before I read it. I'm so smart. The power 3 to the third power is read 3 to the third power or 3 cubed, and 3 to the fifth power is read 3 to the fifth power. They don't all have fancy words like squared and cubed. They're just, those are common ones. So those have fancy words. They don't all have that. So to evaluate the powers, find the value of the power after multiplying. So here's a little chart to fill in. If we have 5 to the first power, that means our factors are just, there's 5, because the first power is just one time, and it's going to be 5. If we have 5 to the second power, then it's 5 times 5, which would be 25. If it's 5 to the third power, then it's 5 times 5 times 5, 3 fives there, which will turn out to be 125. And if it's 5 to the fourth power, that means we're going to have 4 of these 5s here. 5 times 5 times 5 times 5 is 625. I think missing over here is how to write that as an exponent. Oh, whoops. So this would be 5 to the 1, and then 5 to the 2, 5 to the 3, 5 to the 4. You guys get the idea. I don't know if that's in your book or not. Sorry about that. Some of these slides are janky. All right, anyway, what are some mistakes that can be made when evaluating 5 to the third power? I just wanted to talk about this one because common mistakes are people will go 5 times 3. It is not 5 times 3. It is 5 times 5 times 5. So 3 fives multiplied by themselves, not multiplied by 3. The only reason there's a 3 there is to tell us how many fives. Okay, other people might make the mistake of adding, but that's not as common. All right, so try this one out. In the example, evaluate 4 to the fifth power. These slides might be janky, apologies. Okay, so here's how we would write this out. 4 to the fifth power equals 4 times 4 times 4 times 4 times 4. So there's 5 fours because the exponent is 5. And then you multiply it out. And so that becomes 1024. So 4 to the fifth power is 1024, which is kind of annoying to multiply that over and over and over again, but you can do it. All right, try it out with 8 to the fourth power. So, you're going to want to write it out. How many 8s are you writing? And then multiply them. All right, this is example 4. Evaluate 1/3. That's supposed to be a 4 here. So evaluate 1/3 to the fourth power. So again, sorry, my slides, I don't know what's going on. It's not my fault. You would write this out, since the exponent is 4, it would be 1/3 times 1/3 times 1/3 times 1/3. That was 4 times. And then simplify really just means to solve it. And so when you go ahead and do that, you end up with 1 over 81. 1/3 to the fourth power is 1 over 81. You try it, 2/5 to the third power. And that is the end of example 4. And now we've got one last example, I think, example 5. So notice the difference here is we have decimals. You can do these exponents with decimals as well. So 2.5 to the third power It all works the same way, including my slides not working, being broken in the same way. What this should say is 2.5 times 2.5 times 2.5. You can see this on your page, so that's why I'm not bothering to fix the slides. 2.5 times 2.5 times 2.5. That was 3 times because the exponent is 3. And then when you do that multiplication out, you end up with 15.625. That's your simplified. All right, and so you're going to try it with this decimal, 0.2 to the fourth power. And that is the end of the lesson. The key takeaway here is whatever the exponent says, you don't multiply the base times the exponent. You multiply the base times the base times the base, however many times the exponent tells you. And if you can remember that, then you will get these right.